A secant line versus a tangent line. So what we just covered, just to remind you real quick, if you have a circle, okay, first off, if you have a line segment in a circle, what was the name for that? Chord. What if we chop a line segment with a line? That is a secant line. And if we skim a circle with a line, it is called, and that touches it, that is a tangent. So make sure you know those three things. Of course, we already have from previous years, we already know what a diameter or radius is. That might be some more vocabulary that pops up still. A diameter actually is a chord because the endpoints are on the circle. So that's all this is saying here is just to remind you what a secant line is. And let's skip that and go straight to the theorems. Well, or maybe that is the theorem. Yeah, theorem, and then they give you the proof right below it. That's weird. Your next theorem. If two secants or two chords, because we know a secant and a chord is pretty much the same thing. If two secants or two chords intersect in the interior, and you see that. Here you got two secant lines and they intersect right there. Anytime you have two secant lines that intersect in the interior circle, then the measure of the angle formed is 1/2 the sum of the measures of the arcs that's intercepted by the angles. So if you're looking for angle 1 here, okay, you've got two secant lines that intersect in the circle. To find the measure of angle 1, you take this arc and you take this arc, you add them and take half of it. To find angle 2, you would take this arc, you would take this arc, you would add them, and you would take half of it. So inside circle. Once again, to find this angle, you would take the blue arc plus the blue arc, and you would add them, divide by 2. So anytime it intersects, you've got two secants that intersects inside the circle, then you're going to take half the sum. That's what I need you to remember. Two secants intersect inside a circle, you're going to take half the sum. But what about this angle over here? How would you find it? Would it not be the exact same thing? Would it not be the same two intersected arcs? Yeah, well, are these two not the same anyway? They're vertical angles. So anytime two secants or two chords intersect inside a circle, and you're looking for the angles for them, you take your intercepted arc. Remember Pac-Man. Here's Pac-Man. He's eating this arc. This Pac-Man's eating this arc. You take those intercepted arcs, you add them, divide by 2, half the sum. Let's work the problem. On the first one, you see we're looking for angle X right here. In order to find angle X, and here's another issue. Are those central angles? No. If they're central angles, we can simply just look out here, and whatever that angle is, or whatever that arc is, that's what the angle is going to be. These are not central angles. In order to find what this angle is equal to, it's half the sum of the intercepted arcs. This angle is eating this arc. This angle is eating this arc. We're going to take 130 and 84 and add them together. Gives you 214, and then we're simply going to divide it by 2. It gives me 107 degrees. This angle is 170 degrees. This angle is 107 degrees. Any questions on how to find that? Intercepts inside the circle, half the sum. The second one, a little bit different. We're looking for this angle down here. Anybody got a game plan? Linear pair. You got a linear pair there. Why not go ahead and find this one? Because we've got these two arcs. 75 plus 143. Go ahead and add that together. Tell me what you get. Divided by 2. Take half of it. 109. That's half and half, right? So this angle is 109 degrees, but we're looking for this angle. It is 71 because those form a linear pair. So you got 109, 109, 71, 71. Do we know these arcs? No. Is there any way to find those arcs? No. Okay. And the last one. Got to work it backwards. The angle is equal to half the sum of the two arcs. Here's how I work it. If this angle is equal to half the sum, 110 is half the sum. What is the sum? If 110 is half of the sum, then what is the whole sum? Does that make sense what I'm saying? 110 is half of the sum, then what would the whole sum be? 220. Does that make sense? 110 is half of the sum of the two arcs, so the whole sum would be 220, double that. So therefore, the sum of these two arcs is 220. So how do I find out what that other arc is? 97. Good. And that's going to give me, what I would do is subtract 100. That's 120 and then tack back on 3. Any questions? So, and again, that's not going to be the last time you work that. If I tell you that your formula is half the sum, the angle equals half the sum, and they give you the angle, just keep in mind if the angle is half the sum, you can double that and that'll tell you what the whole sum would be of those two arcs. Okay, here's your second one. What if you have a secant or a chord and a tangent? A secant and a tangent. If a secant and a tangent intersect at a point of tangency. Now wait, before we move on any further, is this a diameter or is this a radius? Because we talked about if a diameter or a radius hit a point of tangency, what's true about that angle? Yeah, that's 90 degrees. That is not a diameter, that is not a radius. It's shrunk a little bit, hasn't it? You leaned it. It was a radius or a diameter, but you leaned it a little bit over this way. It's going to make that angle smaller. In order to find this angle, it'll be half the intercepted. Angle 1 will be half of this arc, is all you got to do. Angle 2 would be half of this arc. So in review, if they intersect inside the circle, I'm going to do this every time. If they intersect inside the circle, you do half the sum. If they intersect on the circle, you do half the angle. So here we go. Here's my problems. Looking for a measure of angle QPR. The angle will equal simply half the arc. The arc is 148 degrees. How big is this angle? 74 degrees. All you got to do is half the arc. Y'all see that? Here's Pac-Man. He's eating this arc. That's the intercepted arc. The arc is 148, the angle is 74, and if you wanted to, you could go a step further and you could actually find that. You could also find this. Do y'all see that this has split this circle into two pieces? If this is 148, how do we find this side?
106 times 2.
106 times 2, or what's the other way you could have found it? How many total degrees in the circle?
60.
So if this is 148, this must be the other 212. Makes sense. The next one, again, remember that the angle is equal to half the arc. Angle is half the arc. If the angle is 64, that's half the arc. What's the whole arc?
128.
Could I find this arc as well? 232 degrees, the other part of the 360. Any questions? That's enough of those. And your third scenario. What is this? Yeah. First we did, okay, the angles intersected inside the circle. Then we did the angles intersected on the circle. And the only other scenario we have left, what if we have an angle outside of the circle? Okay. In the circle, half the sum. On the circle, half the angle. Outside of the circle, half the difference. That's all this stuff up here, that's all it's saying. If you're looking for angle A here, you take half the difference between the two intersected arcs, and you got to be careful. You always got to do the big arc minus the small arc, right? So you would do half the difference. So you would do the difference between this arc and take half of it. Notice again, angle A is outside of the circle. To find the measure of angle A, you take the two intercepted arcs because this Pac-Man is eating two different arcs. You would take the big arc minus the small arc, half the difference, and take half of it. Here, this Pac-Man is eating the whole circle. You have a big arc formed, you have a small arc formed. You're going to do the difference between the big arc and the small arc and take half of it. So if an angle is located outside of the circle and it intersects this circle to where you've got two arcs cut off, to find the measure of that angle, you would always do half the difference of the two arcs. Here's some problems. Angle L is formed by two tangent lines. You have, let me scroll here, make this a little bit, whoa, let's not do that. Okay, just kidding. Let's just keep it where it's at. Angle L cuts off two different arcs in that circle. This small arc is 102 degrees, but they don't tell us what the other arc is equal to. I have to add up to 360 because that's the only two arcs in that circle. 102, that leaves you at 258. To find the measure of this angle, since that angle is located outside of the circle, you do half the difference between the two arcs. So 258 minus 102. What'd y'all get when you subtracted them?
156.
Take half of that and you get 78 degrees. That's a 78 degree angle. Any questions? Now, the next one, we're working it backwards again. The angle is equal to, notice where the angle's at. It's on the outside of the circle. So the angle is going to equal half the difference. With me? So if that 56 degrees is half the difference, working just like you did a while ago, what's the whole difference? The difference, if 56 is half the difference, then the whole difference will be double that, 112. So now let's talk about how we're going to find this other arc. I know that since 56 was half the difference, the whole difference is 112. That means the difference between the small arc and the big arc is 112. How do you find the other arc? The difference is 112. If the difference between the amount of money I have and the amount of money you have is 112, yeah. If I have $2, you have $114. The difference is 112. So therefore you take this, you would add on that difference and you would get 217 or 207. Now check it. Since the angle's on the outside, to find the angle, you do half the difference between the two arcs. The two arcs that are being eaten are 95 and 207 degrees. The difference between 95 and 207, if you check it, to find the difference, you subtract them, you would get 112. Take half that difference, you do get 56. Could you find arc BD?
Well, yeah.
Yeah, you can on this one. Since this one's tangent, that's 95 and 207, I believe that adds up to 302, which would leave you with 58 degrees for that arc. So you could on that one. More of that. Anytime the angle is on the outside of the circle, you'll find half the difference. Hunter, help me with this one. Your two arcs that are being chopped up are 179 and 71. What's the difference between 179 and 71? 108. And the angle is equal to half the difference, so it would be 54 degrees. Now on that one again, if I ask you to, you could find that other arc. Extra information, but this is 179, that's 71, that's 250, I believe, which would leave you with about 110 degrees for that other arc. Briley, the next one. The angle is equal to, again, since it's on the outside, the angle is equal to half the difference. If 68, and that's what they're giving you there, I believe. Yeah, because it says, what is the measure of arc XZ? I don't think they're going to ask you for the measure of the arc and tell you it's 68 in the same step. That 68 degrees is actually the angle, okay? Briley, since the angle is equal to half the difference, the angle is 68, what would be the whole difference? 68 degrees is half the difference, so the whole difference would be 136. So the difference between your two arcs is 136 degrees, but this one's different. This one gives you the big arc. How are you going to go back to the small arc? Are you going to add on 136 like you did last time? Because that's going to be 360. You subtract it off. The difference, you got to know whether they give you the big one or the small one as to whether am I going to subtract it or add it on. Since you're given the large arc, it's 224, subtract off that 136, and somebody tell me what that small arc is going to be.
88.
Is it 88? Yeah. No? Yeah, that's right. 88 degrees. And you can check yourself. 224 minus 88 is 136. Take half of that, you get 68. Let's do one more. I like this. The angle is equal to half the difference. We might can do this in our head. If the angle is 25 degrees, Colton, that's half the difference. What would be the whole difference? 50. So the difference between my arcs is 50 degrees. We're given the big arc. We need the small arc. The difference is 50 between the two arc measures. So if the big one's 110, the small one is 60 degrees. Good job. Any questions, guys? Now that's finding angle measures. Let's skip over that. Now we're finding segment lengths. Okay, a little bit different. Everything that we just did was all angles. Now we're finding lengths of line segments, lengths of chords, pieces of chords. And you've got the same scenarios. We've actually already went over one of those scenarios. We'll talk about it in a second. Segments intersecting inside a circle. Let's go back for just a second and remind you about something. You have a circle. You have this X shape. And what we want to do is we're wanting to know what's the relationship between those four line segments. Everybody sees the four line segments, right? You got this small one, this small one, this one, this one. You got four different line segments. And the way I'm going to do that is I'm going to draw another set of line segments. And let's see if you remember this. You got that hourglass looking shape. You've got angle 1 and angle 2 here. Look at those two angles. Do they not both cut off this exact same chord, or excuse me, the exact same arc? Those are both inscribed angles. They cut off the same arc. What's true about angles 1 and 2? They're the same angle. Also, you've got angles 3 and 4 down here. Do 3 and 4 not also cut off the exact same arc? Both of them are eating the same arc, so angles 3 and 4 are also the same. These are vertical angles, so they're also the same. Those two triangles that I just drew, are similar triangles. Now, what about this? Let's take and let's call this little arc or this little line segment A, this one B, this one C, and this one D. If you have similar triangles, don't you have proportions? If we set up a proportion here, A goes with C. Look what A and C correspond with. Okay, A goes from 1 tick mark to 3 tick marks. What does A correspond with in the other triangle? B, at 1 to 2, right? So A goes with B and C goes with D. So how do you solve this? We move this up here, we move this up here, right? So AD would equal BC, would it not? So if you have this scenario, I did all that to give you this little short formula. If you have this scenario, because you've got similar triangles, this line segment times this line segment, that's the two pieces of that whole line segment, right? A times D will equal this line segment times this line segment every time. If you've got an X formed inside of a circle, piece times piece equals piece times piece each time. And that's what this theorem here states. In this circle, you've got these two line segments that's crossing inside the circle. AB times BC will equal EB times BD. That's your formula. Piece times piece equals piece times piece. First problem. If two line segments intersect inside a circle, the product of the pieces that are formed are equal. So in this next problem, see if that makes sense to us. Alex, what times what equals what times what here? 5 times equals. Perfect. Does everybody understand? 60 equals 10 times x, divided by 10, x is 6. We good? Next one's nasty. Okay. Am I going to give you one like this on your test? Possibly, because I want you to get used to those quadratic equations again. Have me set this one up, Jagger. X times 10 times what? Or x plus 10 times times x will equal times, perfect. And I say this is quadratic, but it's going to cancel out. Don't worry. Distributive property, x times x times 10. Distributive property, but two terms, big time distributive to the second power. X times x squared. X times 8, 8x, also known as FOIL, right? We're done with x. 1 times x is x. 1 times 8 is 8. FOIL. So we have x squared plus 10x equals x squared plus 9x plus 8. Oh, this would be an easy one to solve. When you move your x's together, they cancel each other out. Solve it from there on out for me, Matt. Move my x's now to the left side. What are you left with? Equals. Always check it. You've got x is 8, so that means 8 and 8 would be 16. 8 and 1 would be 9. 8 and 10 would be 18, and x is 8. 9 times 16, 144. 8 times 18, 144. Checks out. Let's try this. Let's see what we got. The highest point or apex in the Astrodome is 208 feet high. That's huge. That is absolutely huge. Astrodome, if you don't know, is where the Houston Astros play. Highest point in the Astrodome is 208 feet high. If the diameter of the circle containing the arc is 710 feet. So the Astrodome is pretty much this, is what it's saying. It's the top part of the circle. The highest point is 710 feet, so I would say that that would be a radius, correct? Oop, not 710 degrees, 710 feet. The highest point, oh, hang on. Yeah, so that doesn't match up, does it? Because here's my thought: the highest point is 208, and the diameter is 710. So that highest point is not actually a radius. So what that tells me is it's more like this. That makes sense. It's the top part of the circle. The highest point is 208 feet high. The diameter of the circle containing the arc is 710 feet. How long is the stadium from one side to the other? So let's do this. So what we're going to do is we're going to extend this on further. The diameter is 710 feet, so that means if this is 208, that leaves us with, somebody do 710 minus the 208, I think 502. That makes sense. The diameter is 710. Here's the actual stadium. The stadium is a partial part of a circle. It's that part right there. The diameter of the entire thing, or the diameter of that circle would be 710. So what I did was, since the height of the stadium is 208, I subtracted from the 710, gives me this piece is 502. Now I would assume that this stadium is symmetrical, correct? So let's try to figure out how far is it from one side of the stadium to the other. Anytime you've got two chords that intersect inside a circle, if you're looking for lengths, you've got here x times x will equal 208 times 502. Make sense? X times x, that's x squared. Somebody on their calculator do 208 times 502 for me.
104,460.
104? 104? And then to get rid of a square, we're going to take square root. And x is equal to 323. Now that's just x. Okay, that's just from here to here. So to find the actual entire width of the stadium, let's double it. That'd be 646.2. Just double all of it. So that stadium is 646.2 feet across. Just a reminder real quick before we move on. Do you notice what you did with these two numbers? You multiplied them. This is just a little bit of a review. You multiplied them together, and then you turned right around, and you took the square root of them. What's it called? When you multiply two numbers and then take their square roots. That's your geometric mean. What you technically just did to find this width is you found the geometric mean between 208 and 502. You multiplied them, took the square root of them. Okay, next one. What if they intersect outside of a circle? Because if they intersect inside a circle, you just do piece times piece equals piece times piece. If they intersect outside of a circle, a secant segment intersected to the out, here's your formula. Here's what they give you. They give you AC times AB, which is this portion, is equal to AE times AD, which is that portion. Here's the formula I'm going to give you. Whole times outside equals whole times outside. I just like that one better. It's easier to remember. If two segments intersect outside of a circle, then the whole segment times its outside portion will equal to the other whole segment times its outside portion. So if two things intersect outside a circle, whole times outside equals whole times outside. Now let's use that. Look what you got. These two things intersect outside the circle. Notice the point of intersection is J. We're not looking for an angle. If we're looking for the angle, remember what we do? Half the difference. We're looking for line segments. So let's take this bottom one first. What's this whole line segment equal to? Careful. 16 times, what's its outside portion? Whole times outside. The top one. What's that top line segment equal to? The whole thing. Careful. This is X, this is H. You don't multiply them. X plus 8. The whole thing is equal to X plus 8. What's its outside portion? I'm going to put it in front. Whole times outside equals whole times outside. Or if you want to do outside times whole equals outside times whole, same thing. 96 equals, you can distribute here or you can divide by 8, either one. I'll distribute. 8x plus 64. Subtract 64 gives me 32 is 8x. X must be 4. We plug it in. Gives me a 4 right there. Now let's check it. On the bottom one, whole times outside. What was the whole?
16
times outside, which is 96, right? Now look at the top one. What's the whole?
12
Times the outside is 12 times 8, 96. It checks out. So if that be your scenario, that small line segment on the inside is 4. Okay. Same thing. Notice where your intersection point is outside the circle. We have the same scenario. Whole times outside equals whole times outside. Help me with it, Dylan C. The bottom line segment, what's the whole line segment? How long is it?
9.
Good. Times what's its outside region?
4.
Good. So 9 times 4. Everybody good with that? 9 times 4 equals, let's go to the top one. Trace, what's the whole line segment equal to?
13.
Well, we don't know. This is not necessarily 4. It's just X. We don't know. But you're right. If that be 4, we got to do 4 plus 9, right? If it was 5, we'd have to do 5 plus 9. Since it's X, we do X plus 9. What's its outside part, Trace?
9.
The outside. The part outside the circle would just be the X. Whole times outside equals whole times outside. Clean it up. Gives me 36. Oh, this will be a good one. X times X is X squared. X times 9 is 9X. X squared ain't going to cancel this time, right? Let's go back and let's review how to solve this. This is called a quadratic equation. If you move X squares, try to combine X squared combines with nothing, 9X combines with nothing, 36 combines with nothing. First step, move everything to one side. We now have x squared plus 9x minus 36 is equal to 0. You have multiple methods of solving this. The two that we concentrated most on was factoring and quadratic formula. I hope we can factor this. Yeah, we can. To factor this, we ask ourselves two questions. I need to know what set of numbers adds to give me 9 and multiplies to give me a negative 36. So, good. 12 and 3 gives you that 36, and it'll also give you a 9 because one of them's got to be positive, one of them's got to be negative. It's going to be a positive and a negative. There's two answers there. My two answers for this quadratic equation, my first answer is negative 12, and my second answer is positive 3. Look at that problem. Here's x. X is the distance from here to here. Is that negative 12? 3 is the only possible answer. So x is equal to 3. So even though we ended up with a quadratic equation, we were able to dump one of the answers because x can't be negative 12. So now let's check it. Whole times outside. We've already done this bottom portion. The whole is 9, the outside is 4, you get 36. Check the top one now. Whole is 12, outside is 3. 12 times 3 also 36. Next one. Nearly done, folks. Top portion, Carly, whole times outside. What's the whole portion equal to? Times what's the outside region? So 19 times 7 is equal to the bottom portion, Hunter. What's the whole region?
X.
And what's the outside part? So whole times outside equals whole times outside. That's 70 and 63, which would be 133. Is that right? Equals 6x plus 36. Somebody's got a calculator, check me on this. Subtract 36, I get 97. Is that right? Is equal to 6x. Divide by 6, I get 16 with 1 left over. If you want it as a fraction, probably look a little bit better. 16.16666. 16.16 repeat. So that's 16 and 1/6. And again, for those of you that don't remember, to divide 6 into 97, you get 16 wholes with a remainder of 1. You take that remainder and you put it over what you're dividing by, 16 and 1/6. And if you want to check that, you can do 1 divided by 6, and that is 0.16666. So therefore, my missing region is 16 and 1/6, or 16.16 repeated. Last scenario. What if you have a secant and a tangent? It's the same formula. Whole times outside, because look, on the bottom, the whole piece is JM times the outside piece is JL. And that whole times outside still. Equals, okay, look at your other one. What's the whole piece equal to? JK. How much of that is outside? JK. So whole times outside equals whole times outside still applies because on this side it's JK times JK or JK squared. So if you want to just remember the one formula and you can apply it to both, the way I remember it is if your intersection point is outside, you always use whole times outside equals whole times outside. Whoa equals whoa. Let's try it. Briley, the bottom one. Let's do it first. Whole. What's the whole part of the bottom?
7 plus X.
Good. And what part of that Briley is on the outside?
X.
So there's whole times outside equals the top one. Colton, what's the whole piece of the top equal to? 8. And how much of it is on the outside? 8. So that'd be 8 times 8 or 64. 8 squared. That's the reason in the formula they just do 8 squared. So you have now x squared plus 7x equals 64. Hey, it's another quadratic. Nothing cancels. X squared plus 7x minus 64 equals 0. We've got to ask ourselves what adds to give us 7 and multiplies to give us 64. You could go through your whole list. And like I said, 8 times 8. That multiplies to give you 64. That doesn't help you. 16 times 4 doesn't help you. 32 times 2, we're getting even further away. That's not factorable. Anytime something is not factorable, this would be a good review for you. If you didn't remember it, you might want to write this down. Let me do it in a different color. If something is not factorable, that's when you use what's called the quadratic formula. Negative b plus and minus the square root of b squared minus 4ac all over 2a. What part do you do first? Remember that? It's called the discriminant. If you end up getting a negative answer for the discriminant, you can stop there. There's no answer, okay? Because you can't take the square root of a negative yet. So let's do our discriminant first. B squared, and just a reminder, your A, B, and C. A is 1, that's A. B is 7. C is negative 64, the numbers. The coefficients out front and the constants are C. B squared. Help me with this, Alex. What's B squared?
B is 7.
Yep.
49.
So 49 minus, Alex, do them all three together. 4 times A times C. 4 times 1 times negative 64 will give you a negative 2. Negative 256. Put those two together, that gives you 305, I think. And guys, we don't know the square root of 305. You can try it, it's going to be a decimal. That's the reason this thing will not factor. So now let's plug in the rest of it. So here's your final answer. Here's what you're going to have. Negative b is negative 7 plus and minus the square root of 305 over 2 times a is 2 times 1, which is 2. That tells you absolutely nothing, probably. What kind of answer is that? We don't know. Okay, let's actually change that to a decimal just so it looks more like what we're used to seeing. We got two different answers. Our first answer is negative 7 plus the square root of 305 divided by 2, which is about so on your calculator, 5.2 rounded. So on your calculator, you would type in the square root of 305 plus negative 7 divided by 2, and you get, what do you say, 5.2? And honestly, I don't have to do that again. Because my next answer would be negative 7 minus the square root of 305 divided by 2. Because that's what that plus or minus means. Does anybody see a problem with that answer? If you do a negative minus a number, will that not be a negative on top? You'll see that negative this, put them together, you're going to get a bigger negative. Divide that by 2. Is it positive or negative? It's negative. Can x be a negative value? Nope. You don't even have to work that one out. So x is about 5.2. And you can check that. Whole times outside equals whole times outside. The whole answer here would be about 12.2. The outside region is about 5.2. Does that equal 64? Do 12.2 times 5.2. 63.44. Why is it not equal 64? Because that is a rounded answer. Now, is that close enough to where we can confidently say, yeah, that's probably the answer? Yes. Last problem again. AB is tangent to the circle. Find the value of x. Whole times outside equals whole times outside. Now, this one a little bit tougher. Look at this. What's this whole equal to? X plus 4. Would that not be 2x plus 4? X plus x is 2x's, and then plus x plus 4. Times outside is x, equals whole, which is 10, outside, which is 10, 100. X times 2x is 2x squared. X times 4 is 4x, and equals 100. Let me show you a trick. Now we're getting into some algebra, but I want y'all to know that this is true. When you're solving equations, y'all notice 2, 4, and 100 are all divisible by 2. You can clean this thing up. You can actually go through in the same way you reduce fractions, you can reduce equations. As long as you do it to everything. Divide everything by 2. Gives you x squared plus 2x equals 50. I would rather solve that. It's just cleaner. Move the 50 over. You have x squared plus 2x minus 50 equals 0. Again, it's a quadratic equation. We ask ourselves what as, if it's factorable, we ask ourselves what as to give me 2, multiplies to give me 50. You could go through your whole list, 5 times 10, 25 times 2, you're not going to find anything, which again means that is not factorable. So now we go into, since it's not factorable, quadratic equation. The first step of your quadratic equation is the b squared minus 4ac. Always perform that first. B squared minus 4ac, let's work it together. What's b squared? Minus 4 times 1 times negative 50. Isn't that? No, 4 times. 4 times 1 times negative 50 is negative 200. So yeah, pretty much 4 plus 200, which is 204. Your quadratic formula is negative b plus and minus the square root of that stuff over 2a. Now let's plug the rest of it in. Negative b would be negative 2 plus and minus the square root of 204 over 2 times 1, which is 2. Now let's find our two answers there. Which again, think ahead. Will we really have two answers? You have a negative number plus a positive. We're okay there. But then you have a negative minus a negative. Or excuse me, a negative minus a number, which will give you a big negative. You can dump that one. So really the only answer that we have to worry about is negative 2 plus root 204 divided by 2. So let's do root 204 first. What y'all get for that? Root 204 is about 14.3. We've got to add negative 2. What's the easy way to add negative 2? Subtract 2. Then divide your answer by 2, and you get about 6.1 if you round. So your missing portion there, x is about 6. This is 6.1. This would be 10.1. Now there's one scenario we left off. We went through and said, okay, what if it intersects inside the circle? What if you have like a secant line and a secant line intersecting, or a chord and a chord inside the circle? Then we talked about, well, what if you have like two secants that intersect outside? And we did whole times outside equals whole times outside. Then we did, well, what if you have a tangent and a secant that intersect on the outside? And you did whole times outside equals whole times outside. Do you remember which one, or do you know which one we left off? We did 2 chords inside. We did 2 secants. We did a secant and tangent. We did do 2 tangents. How do we find the distance when you're talking about 2 tangents? Have we done that yet? We did it, didn't we? If you have 2 tangents, is that not your clown hat? Remember that? If you have 2 on the outside, then those 2 tangent lines will be congruent. So that is all your different scenarios.